चलो चलो okay, so sorry, I forgot the what is it, the attendance sheet, so now I have sent it to you guys, so please put the attendance. Whew. Was there a class for you guys just before this lecture?
No, sir.
Okay. Just wait maybe one more minute. So we've hit the 50 mark. I think that is the mark which I don't really expect more people than 50 in the class. So I think we can start now. Okay. So in the first lecture for the so with this week is all about polymorphism, right? And polymorphism, as we now know, we have an idea of what polymorphism is. So the idea is that basically the same thing, but it has different morphs, right? That is what that biological term told us, polymorphism. So so there are different forms in which you can see polymorphism in object-oriented programming languages. So today we are going to discuss one of the more common forms, and this form is essential because not just in C++ but in almost all the languages you have support for this type of form overriding, and it is also the preferred way of showing how behaviors change from one class to another class, right? So you can always create new methods in the derived classes which do the same thing. Let us say, so for example, you had a method called func in class A. Now when you created a class B deriving from class A, you can probably create another function func2, right? Because you don't want to override, or you don't have or let's say the language that you are using does not allow you to override. Um, but this is the preferred way, right? I mean, if the behavior is exactly the same, but there is certain changes for class B for that behavior, you should always override the function, the behavior of the superclass, rather than providing it as a separate new behavior in the type class. So overriding, let us start. By the way, any questions from the previous lecture? This one is actually a shorter lecture, so I will probably finish off much before time. So let us revisit the virtual functions that we've seen, I think, in the first, or maybe in week 3 or week 4, something like that. So the idea of a virtual function is that a function that is declared as virtual means that there is a chance, there is a probability that this function might actually be redefined in a derived class. Okay, that is the overall idea. So from the perspective of designing, what I say is that it represents a behavior of a particular class which is open to extension or modification. So a derived class may or may not. That is the idea, right? I mean, at least in C++, when I say virtual, it doesn't mean that the derived class is forced to redefine it. Okay, the forced part comes in when it becomes a pure virtual function. Any questions? Okay. Yeah, but otherwise, if it is not a pure virtual function, then it is not necessary for the derived classes to redefine it, but they may redefine it. That is the idea. Okay. Now, the changes that you see in this new definition can be categorized in two different categories, right? So you can call it modification. So you basically say whatever was the definition for this particular behavior in the base class, it is significantly different from that for the derived class. Okay, so I, in essence, I replace the definition of the base class with a new definition. Another way is you can say there is some kind of extension as in, no, the base class behavior is still valid. It's just that the derived class also has something more to it. Okay, so in this case I call it extension. Please keep in mind that these are two ideas only for at the level of design. At the level of code, it doesn't matter. Okay, as soon as you redefine a function, it doesn't matter whether it is modification or extension. Okay, it doesn't matter. It's more of the it's more about how you think about it. If you want to override a function, what should be your thinking process? You should think that whether I want to modify the behavior or whether I want to extend the behavior. That is the idea. Okay. But either of the two cases, what you are really going to do is you are going to flag this particular method as virtual, and this virtual flag needs to be given only once, as in, let us say you have a whole hierarchy of classes. So let us say a, the base class is a, then b derives from a, then c derives from b, then d derives from c. So there is a whole hierarchy. It doesn't mean that you have to define it as virtual in all these classes. No, wherever it was added, so let us say it was added in class a, you just say this method is virtual. So then from there onwards, you don't really need to provide any more explanations. Okay, you treat it like a normal function. If you provide a new definition for this function, it is considered overriding. Otherwise, you can always keep on using the definitions that were provided in the previous classes. So how do you do that in C++? You do that by using the virtual keyword in C++. You prefix the virtual keyword with to the declaration of that particular function, and this information can also help you exhibit polymorphism. I'll just tell you what this means. But no, before we go ahead and talk about polymorphism and how overriding is associated with polymorphism, a basic definition of overriding: the process of providing a new definition for a virtual method from a base class is called overriding, right? So again, this virtual method part is because I have tailored this definition for C++ users. Otherwise, there are different terms that we use for it. Okay, so for example, another term that is used is abstract method. So if you are a Java programmer, the terminology that you might be more aware of is abstract methods. So that abstract and virtual are kind of the same thing. It's just that abstract are essentially pure virtual methods, whereas virtual is somewhere in between. Okay, it could be pure or it may not be pure. So the new definition, as I said, can be completely different from the base class definition, or you might, it may add some logic to the existing base class definition. That is the idea. So let us say this is my base class definition. I've written something here. Then there are two ways logically to override this. One is I simply write something completely new here. Another way is I write some logic, then I make a call to this base version, and then maybe I add some more logic. So essentially, in some ways, this is just an extension of the existing behavior. It's not like the existing behavior is not going to be invoked. It is going to be invoked, but I want to do something more before or after this particular logic gets executed. Okay, so that is, again, by the way, from the and this is the example of that. This is the start playing method from the toy2 class. So this is the definition in the base class. By the way, I did declare this method as virtual. I have not put the declaration here, but this method was declared as virtual. So now, this is an example where I have provided a completely new definition in the derived class, battery operated toy 2, there's a completely new definition. And in this plain toy, I'm just, I've put one additional cout statement, and then I'm just calling the base class versions. And so this is in some ways extending the existing definition of start playing. Okay. So this is just to give you an idea of what I meant when I said modification versus extension. Keep this in mind that this uh, uh, all these differences between extension and modification at the level of compiler, it doesn't make there is no difference whatsoever, right? So compiler doesn't differentiate between modification and extension. For it, there is a new definition, that's it. But this is more of a design level decision, that when you override a particular method, what exactly is it that you're trying to do with it? Okay. So this virtual keyword, what it really does, it gives a hint to the compiler that please keep on looking for new definitions of this particular method. So there might be multiple definitions available for this particular method. That is what this virtual keyword does. Okay. So it essentially says it is possible to redefine a method in a derived class. So this is the part that you have to understand, that it is possible to redefine a method in the derived class even without using that virtual keyword. Okay. But and many a times this is one of the most common forms of error that programmers do in C++ when they are using overriding. They forget to make that method in base class as virtual, right? I mean, why? Because in many cases you will not be able to see the difference. Okay, I'll just show you an example of such cases where you will not be able to see the difference. But keep this in mind: without flagging a particular method as virtual, you can still provide a different definition for it in the derived class. It's just that it is not really overriding. It is known as name hiding. Okay, it's rhyming, I know, but yeah, the idea is it's not overriding, it's name hiding. So what is the difference between overriding and name hiding? Basically, you are not really replacing the version of that functions definition, right? So as I said, overriding means you replace the definition in the base class with one in the derived class. So no, you don't really replace anything when you are doing name hiding. You're simply hiding it. Okay. uh, what I mean is, I think this might not be showing you properly. Okay. So what I mean is something like this. Let us say you guys remember what happens when you declare a variable of the same name in a smaller scope, even though you have a variable with the same name in the enclosing scope. So for example, you have a global variable called x, and then within main, you again create something like int x. Okay, so what happens? So from there onwards, wherever you try to assign a value to x within main, it is not the global x that is accessible to you. It is the local x that is accessible to you. So in some ways, the global x is still there. It's not like global x has vanished. It's just that for this scope, you've just hidden the global x from the local x, that's with the help of the local x. So the same thing happens here. If you redefine a method in a derived class, and that method was not a virtual method, you're not really overriding. What you're doing is you're just hiding the definition from the base class, and instead you're just putting the derived class definition over it. So in fact, in many cases, with this is why it becomes a problem, because many test cases that you try out will give exactly the same output as in the case of overriding. So you might be tricked into assuming that you've done the right thing. But the moment you start using pointers, for example, and for specific use cases like the one we saw in the previous lecture, where we were putting the toys on sale with the help of a pointer to the base class, the moment you use your objects for such scenarios, this is where the code will break. This is where you will realize that, oh, that function was not really virtual, and I thought I have overridden it, but I really haven't. So what I'll give you an example here. Let us say you have a class called base. It has two methods. One, as it says, is non-virtual, and the other one, as it says, is virtual because I have put the keyword virtual before it. And then I have some very simple definitions for these functions. It's just a printing, just a cout statement which says that this particular method has been invoked. Similarly, I also have a derived class. This derived class is inheriting from the base class, and the same two methods with the same name, right? Non-virtual method and virtual method. By the way, you can see that I have not used the virtual keyword here. It is not required here. Okay, it was only required in the base class. It's not required here. And another thing that you have to keep in mind is, even if you are overriding an existing method which is whose definition is already present via inheritance, you still have to do the declarations. Okay, these declarations are still required. So that is why I had to put this. So the definitions are again very simple. They're just a cout statement. This time it says derived instead of base. So now let us try to see what really happens. Okay, I have two classes, base and derived, and they both have these two methods, virtual method and non-virtual method. I also have two pointers, a base class pointer and a derived class pointer. And now this is what we try to do with it. So these method calls are very simple, and in fact this is why many a times people don't realize that they have made a mistake, right? What am I doing here? First, I'm using this base class object. I'm calling the non-virtual method. I'm calling the base class object and calling the virtual method. Similarly, derived class object non-virtual method and derived class object virtual method, and the output is exactly as expected, right? I mean, in the first case the two base class methods are invoked, and in the second case the two derived class methods are invoked. So it's pretty simple. And as I said, if even if you forgot to make that function, the virtual function, as virtual in base, this output might make you feel that no, everything is right. No, there's no problem with my code. But this is where things become interesting. So now, instead of calling these methods directly with the help of those objects, let us try to do that via pointers, right? This is what we did in that put toy on sale example, right? We were having a pointer, and we were passing different types of objects to that same pointer, and we said this is the advantage of polymorphism, that this pointer can actually point to different types of toy classes, even if they are not really toy classes, but it's derived classes. So let us now try to do the same thing here. I have this base class pointer as well as this derived class pointer, and both these I'm pointing to at the derived class object. So now what I do is, with the help of this pointer, I again call these four methods: BP non-virtual method, BP virtual method. Right? So now, from what we understood last time, right? That uh, the only methods that you can call with the help of a base class pointers are the methods which were defined in the base class. But here, because both the methods are defined in both the classes, you might feel what really is the difference here, right? So here is the difference. So when you use the base class pointer and you call the non-virtual method, the definition that is shown to you is the base class version. However, when you call the virtual method with the base class pointer, it is the derived class definition that is invoked. Okay, why it is so? Because this is an aspect of polymorphism, that even though you are using the base class pointer, you were able to invoke the derived class definition. This is something that we did not know till now, right? This is what I told you, that the only members accessible to you via the base class are those which are defined in base class. But this is where virtual functions come into place, that this method, virtual method, was a part of base class, but now its definition has been replaced by this one, this new derived class definition. So, and because I made it virtual, the compiler will figure out that there is a replacement for the definition of this method, and instead of calling the base class version, it will call the derived class version. So the difference between name hiding and this overriding is that in name hiding you simply hide the scope. The scope of that function is hidden, right? And that is why when I tried to access the non-virtual function, the non-virtual method via the base class pointer, it did not invoke this version. Okay, it simply invoked the base class version, because for it this version is not at all accessible. But for the virtual function, it was able to replace the definition with the new definition. Okay, I know this is a very complex this was a complex set of 10 minutes that I talked about, but let us discuss this. Anyone who would like me to repeat this, or who did not get the difference between name hiding and operator overloading, sorry, overriding. I just taught operator overloading to your friends. So anyhow, anyone who has any questions on this?
Excuse me, sir.
Yeah.
Sir, when we declare a function as virtual and we are calling it from an object of base class, so base class definition should work now.
Yes, yes.
So here,
Right,
why
right, right.
the derived
Yeah, so
class?
basically that is the difference. When you're calling it with the help of the object, then the object thing so it's like this. The only difference that comes in here is when you use a pointer to access the methods instead of the dot operator. Okay, so the difference is between this arrow operator and the dot operator. If you use the dot operator, then everything is explicit, right? Explicit as in you put the type of object before, then the dot operator, and then the method name. So then it's pretty simple. Whatever is the type of the object, the definition that gets invoked is mapped to that type. But in case of pointers, the difference here is the same base class pointer can point to objects of a varying number of classes. Okay, the type is, let us say, base asterisk BP, but this BP is currently pointing to ampersand D, right? And so there is a mismatch between the type of D and the type of BP, right? And that is what I said, that as long as they are compatible, I can do this. Is it clear? So basically, the only problem, and that is what I said. If you are using name hiding and you are using the object dot method name convention, name hiding and overriding will basically produce the same result. And that is why you may be tricked into you may be tricked into believing that you have overridden the function. But true overriding is when the definition of the function is replaced by the new definition. And in order to check whether that has happened or not, you will have to call that function using the base class pointer. If even using the base class pointer you get the derived class definition, then you can say that the function has been overridden in the derived class. Otherwise, as I said, here this is the example, that even though you provided a new definition for non-virtual method in the derived class, and you called BP arrow non-virtual method, the derived class version should have come here. But that did not happen. Why? Because the derived class version for this function is not overriding, but just name hiding. Is it clearer? The idea is that if you want to replace the definition, it has to be a virtual function. Otherwise, you are just hiding the definition. You're just putting a definition on top of another. And as long as you are calling the methods with the help of an object and not with the help of a pointer, the compiler will do as you expected. But the problem starts when you have a scenario like the toy scenario that we had last time, right? Where I was saying put toy on sale, and then uh, uh, I was using the base class pointer, and I'm invoking I'm using it to point to different types of objects. I still don't know what exactly is it that is bugging you. If you can be a bit more clear, I'll try to clarify that part. If there are any more distinct queries, I can try to answer them. So I do understand that this might be slightly confusing. The best way to learn this is just download that code, okay, the code that is available online on the Google Drive folder. Download the code and then try to run it, try to execute it. Okay, then you will understand how is it differing, right? How is it that this name hiding is different from overriding. Okay, if you run the code, you'll probably be able to understand. It'll produce the same output, but play with that code. Uh, uh, try to put in many other types of permutations and combinations, um, and then see what is the output. So anyhow, any questions on this? Any more queries on this? Otherwise, we are done. So as I said, this one is a is a smaller lecture, but the only what can I say? The knowledge that you should extract from today's lecture is that there are two distinct concepts: name hiding and overriding, and you should be able to differentiate between the two. Okay, and usually whenever people are actually doing name hiding, what they really wanted to do was overriding. Okay, and I personally do not know if there is any case where I would like to do name hiding. Okay, name hiding is kind of an accident, to be honest. Okay, so most of the time the developers simply are tricked to feel that they have overridden a method when they have actually not. Okay, so just from today's lecture, just try to understand how these two things differ from each other. Okay, how, what will be the repercussions of performing name hiding versus performing overriding. If you are able to understand this much, I think that is it. That is what I wanted you guys to know after today's lecture. So any questions? Otherwise, we can break. Okay, one point from my side. I did hear that many of you neither attended the practice lab nor informed your TAs yesterday. So this is something that please don't do, right? I mean, these practice labs, the TAs are going to sit there for two hours. It is perfectly fine if you don't want to come. It's an optional thing, but at least inform your TA that I will not be coming to the lab or whatever it is. Um, this should be uploaded, right? I mean, I have not uploaded the slides for tomorrow. I guess I will do, but let me see. Just a minute. Overriding should be there. Lecture slides, week 5. There's something wrong. Yeah, I'm not sure what is wrong. Yeah, it is there. Overriding slides are there. Sorry. So, and the overriding examples are also there. Okay. The overloading, the third part that we will discuss tomorrow. I still have to upload the slides and the examples online, but up to 5.2 it is there. Yeah, so if there are no queries, I was just saying that please, in the next week also we might have a practice lab, but after that we'll have two lab exams. Okay, I'll plan when to have those two exams. We'll only have two exams, and both of them will be compulsory, and your final grade will be based on those two lab exams only. But I, we can afford to have some more practice labs. That is what I was trying to say. So please make use of these practice labs to hone your skills, right? I mean, if I give you a problem, the idea is not really to build a complete system. The idea is that you put your mind at work. you try to design that system using inheritance and polymorphism or whatever concepts you've learned, and see how much you've been able to grasp, how much you've been able to absorb, because this is a difficult topic in some ways to teach as well as to learn. Okay, if it's just theory, you might not even understand what's going on. Okay, they are just concepts. Unless your brain is able to apply those concepts on real world scenarios, you will in fact very quickly forget these concepts as well. So these practice labs, even though they might seem to be a drag because I'm giving you open-ended questions, and they are not really as interesting as writing data structures code where there is a specific input and a specific output. I understand that it might not be thus that interesting, but please keep in mind that from the perspective of learning, from the perspective of you becoming a better computer science engineer, all these things are important. Okay, because um, I don't think anyone will teach you this other than maybe something in the software engineering part. But in software engineering, there will be many other things to learn as well. So this will just be some part of software engineering. There will be many other things. Like there will be testing, there will be requirement gathering, and so many cases will be there. So you won't get so much time on designing. Okay, so use up this semester's time to learn some designing skills. That is the only thing I'm trying to say. Okay, you'll get to write a lot of code in your life, but usually no one teaches you designing. You have to learn it on your own. So use this opportunity to apply some designing concepts. Try to be creative with your mind, and see what is the output. Talk to your TAs, show them what you've done, and take their feedback. Okay. Okay, so you have to submit the project details by Friday, right? Please keep this in mind. And if you're not able to find someone to make a group with, please send me an email. I'll see. Or despite your best efforts, you're still not able to come up with a project idea. In that case, also send me an email. But we have to do this by Friday, okay? So that we can do something by next week. Okay, any more questions? Okay, guys, then bye.